Welcome all. In last lecture we have seen what is encoder, types of encoders and study of encoder ICs. Today we are going to learn regarding decoders. Decoder, here the word is decoder, not encoder. Decoder is a combinational circuit which has n number of input lines and maximum of 2 raised to m output lines. This is the block diagram of decoder, which is identical to demultiplexer without any data input. It performs operations which are exactly opposite to those of an encoder. If suppose there are two inputs, then the decoder will have 2 raised to 2 outputs, that is 4 outputs. If there are 3 inputs, then decoder will have 2 raised to 3 outputs, that is 8 outputs. Now these are the types of decoder: 2 to 4 line decoder and 3 to 8 line decoder. Now we will see one by one. The first is 2 to 4 line decoder. This is the block diagram of 2 to 4 line decoder, which has two inputs, namely A and B, and 4 outputs, namely D0, D1, D2, D3. Each output is 1 for only specific combination of inputs. Means if inputs A and B are 0 0, then D0 will become 1, rest all other outputs will be 0. When AB is 0 1, then D1 will become 1 and all other outputs are 0. When A and B are 1 0, then D2 will become 1 and remaining all other outputs will be 0. And when last A and B are 1 1, then D3 will become 1 and all other inputs are at 0 level. Outputs are at 0 level. That thing is represented in this truth table. Here are the inputs are taken A and B, and the 4 outputs are D0, D1, D2, D3. When A and B are 0 0, then D0 is 1 and all other outputs are 0. When A and B are 0 1, then D1 is 1, all other outputs are 0. When A and B are 1 0, then D2 is 1 and all other outputs are 0. And lastly, when A and B are 1 1, then D3 is 1 and other all inputs are 0. Depending on this, the output equations can be written as D0 equal to A bar B bar, D1 equal to A bar B, D2 equal to A B bar, and D3 equal to AB, considering only a logic 1 output. And using these output equations, we can draw the logic diagram. There are two input lines A and B, and using NOT gate, A bar line is drawn and B bar line is drawn. To get A bar B bar, a AND gate is used, to which A bar and B bar are connected as an input. To get A bar B, another AND gate is used, to which A bar line and B line is connected as an input. To get AB bar, another AND gate is used, to which A and B bar line are connected. And lastly, to get AB, A line and B line are connected to the another AND gate. This is how we can design a 2 to 4 line decoder which converts a 2 line into the 4 line output. Next we will see a 3 to 8 line decoder. This is also similar to 2 to 4 line decoder, only the difference is there are 3 inputs and 8 outputs. and in 2 to 4 there are 2 inputs and 4 output. The 3 inputs are A, B and C, and 8 outputs are D0, D1, D2, D3, D4, D5, D6, D7. Similarly, the truth table is same if we compare it with the 2 to 4 line decoder. As the inputs are 3, the possible combinations are 8, and for each input combination any one of the output line is at logic high level, and remaining all the output lines are at logic low level. For example, if we consider first input combination 0 0 0, for that only D0 line will be high and all other output lines are at 0. So for D0 the output equation will be A bar, B bar, C bar. In the same way, all other output lines are at high level with their respective input combinations. If we take this one 0 1 1, for that D3 line is at high level, all other lines are 0. So the equation for D3 will be A bar B C. In the same way, all other output equations can be written, and using this output equation we can draw the logic diagram for 3 to 8 line decoder. These are the input lines A bar, B bar, C bar, and as per the output equations AND gates are used, and to all these AND gates their respective input variables are connected to work it as a 3 to 8 line decoder. Now next we will see a 4 to 16 line decoder using 3 to 8 line decoder. Means like multiplexer tree or demultiplexer tree, here we are going to construct a 4 to 16 line decoder using 3 to 8 line decoder. To implement 4 to 16 line decoder we require 2 3 to 8 line decoder, so that we will get 16 output lines. Now we want only 4 input lines, therefore all the 3 input lines of both the decoders are connected together to make common 3 input lines. The fourth input is used to enable one of these 3:8 decoders. We cannot keep both the decoders enabled at a time, therefore enable terminal is used and A is applied to the enable input of decoder 1. A bar is applied through a NOT gate to the decoder 1, and A is directly connected to the decoder 2, by which any one of the decoder will be enabled at a time, so that we can get exact output on the 16 output lines of the decoder. So this is how we can construct 4 to 16 line decoder using 2 3:8 decoders. Similarly, a 5 to 32 line decoder can be constructed using 4:16 decoder. Here also 2 4:16 decoders are used, which forms 32 output lines. After that we require 5 lines at the input side, therefore both the 4 input lines of decoders are connected together to form 4 lines, and fifth line is used to enable one of the 4:16 decoder, and a input is applied to the enable input of decoder 1 through a NOT gate, and the same input is directly connected to the decoder 2, and which will form a fifth line of the 5 to 32 line decoder, and which will help to enable any one of the decoder at a time. Now next we will see how demultiplexer can be used as a decoder. First we will see how 1:4 demultiplexer is used as a 2:4 decoder. Now In 1:4 demultiplexer, there is a one data input, two select lines S1 and S0. This is the data input line, two select lines S1 and S0, and four output lines Y3 to Y0, and a enable input terminal is there, by which a demultiplexer can be enabled or disabled by connecting proper input to the enable input terminal. Now, in order to operate this demultiplexer as 2:4 decoder, we have to use the select inputs as a input variables. These are the select inputs which are to be used as a input variable. We are not going to use data input terminal. We are keeping it as a open. We are not connecting any input to that line, and Y3 to Y0 outputs are used as a four output lines of the decoder, and enable input terminal is connected to the logic 1, by which the decoder can be enabled to perform its operation. So this is how we can use 1:4 demultiplexer as a 2 to 4 line decoder. In the similar way, we can use 1:8 demultiplexer as a 3:8 line decoder. The 1:8 demultiplexer is having again a single data input, 8 output lines and 3 select lines. In order to operate it as a 3:8 decoder, we are going to use the 3 select lines as a 3 input lines. We are again going to keep the data input line open. We are not using it for any purpose. Again, the 8 outputs of demultiplexers are used as a 8 output lines of the decoder, and enable terminal is connected to +5 volt or logic 1, by which the decoder can be enabled or disabled. So this is how we can use 1:8 demux as a 3 to 8 line decoder. Now next we will see how to implement a boolean function using the decoder. Here one example is given. We have to implement the given equation using 3 to 8 decoder and external gates. So for that, if we observe the equation, it is a SOP form of equation, boolean expression, which contains the decimal digits 2, 4, 5, 7. This is a 3 to 8 line decoder which is having 3 inputs, that is, these are the inputs A, B, C, and 8 output lines. Out of those 8 output lines, we are going to OR the output lines Y2, Y4, Y5 and Y7 to produce the required output. We are going to keep open remaining all other output lines. We have considered only the output lines which are given in the boolean expression. This is how we can use a decoder in the implementation of boolean function. Thank you.